I mean, to answer that question, we need to go back and understand a little bit of policy making in this country and what has plagued policy making in a large part of the world and particularly in India. So to begin with, we have to understand that we are talking about a collection of states which are like countries in itself. So we are culturally different, we are linguistically different, our climates are different, which means we cannot have a one-size-fits-all approach. Okay, so to have the most effective policy, we have to probably create structure for each of these individual states. That automatically means two things. One, you cannot scale up, okay, and two, you have to get into very nitty-gritties, and that would mean an enormous amount of data collection, processing, gathering, and trying to do that kind of that kind of stuff, which is very expensive, and especially for a country like India, it is expensive not only in terms of the money, it's expensive in terms of the time. So if I have to give a small example, the data which we primarily use for policy making are the surveys done by the NSSO, okay, the National Statistical Service Organization. And what they do is they actually do a pretty good amount of survey. They do about 1,20,000 households, which they try to survey every year and collect various kind of information. And if you think about it, we have about 250 million households, and 1,20,000 forms a minuscule percentage of that. So if you want to do more survey to get a decent sample size, you will never be able to complete the survey in a given time. There is no point starting a survey in 2017 and then being able to finish only in 2019, because you have to take a decision. So you have to do it in 1 year, and the best what you can do in 1 year is a small sample survey. Clearly, anything which you do based on that is going to be less than accurate. So that's one particular problem. The second problem which the policymakers in this country has found out, or we are trying to handle this issue, is whenever you are trying to gather information about a group of people, you want to find out whether they need something, are they poor, do they have a good agricultural output, or etc., so on and so forth. You inevitably you have to go and ask them directly. And then what we economists call is we are going to have a problem of moral hazard or adverse selection, basically asymmetric information. As a result, what happens is any policy which you have targeted, either those policies, there's a lot of wastage. I've targeted something, but the unintended beneficiaries get benefited, that's a leakage, or there are some intended beneficiaries whom we can never reach. So it's not an effective one. Now this is where analytics actually comes in. So how will it help? Because one of the best things analytics does is it says, you know what, we are not going to look at the traditional way of collecting data. We are going to look at very unstructured data in terms of text, data in terms of videos, data in terms of images, and then we're going to use that data to be able to see how we can help the government, which would mean that we don't have to have boots on the ground to collect the information. That saves us time and cost. And we are going to collect or going to use a data which cannot be manipulated. A data which is not generated by asking people, what do you feel, or are you hungry, or are you poor, but it's a data which is out there, which cannot be refuted. If we can process that data well, we actually have a good policy platform. So I think that's the reason why I think governments are going to be the biggest beneficiaries, because of the kind of advantages they're going to have. So as we were discussing about how we can look at unusual data to solve some of the problems using analytics. So let me kind of take you through one particular example which I find quite interesting. And although we will not be able to solve the entire problem, but I think I should be able to give you some idea about how does one go about solving problems like this. So let's start with the Google Earth image, and it's got a pretty good resolution. And I want to zoom to a particular place, and this place is called Moushuni. It's an island in South 24 Parganas of West Bengal. So let's kind of zoom to that particular place, and it will take a little bit of time to zoom, and here we are going. And what we get to see is we have narrowed down the island. And let's kind of zoom out a little bit just to understand the context. This is the Bay of Bengal, and if you see a different kind of color next to the Bay of Bengal, this is where the river Ganges and all the other tributaries come and meet the ocean. This is also the largest mangrove forest in the whole world, the Sundarbans Delta. This line is what separates India and Bangladesh. Some part of this line goes through the land, and there is this river which is separated by it is a river which separates the two countries. What you can see also are patches of dark green and patches of light brown. And no point for guessing what they are. The patches of dark green are the reserve forest, the mangrove reserve forest, whereas the dark brown is the human habitation and bit of a cultivated land. Just to get a context, this is where Kolkata is, and the place which we are looking at, a place called Mushuni Island, is about 100 kilometers from Calcutta and right on the edge of the sea. So it's kind of down south. Some other interesting facts before I kind of zoom in. Let me kind of zoom in as much as possible, and we're going to get a reasonably good resolution. And this is the forest which we can see, and there are these rivers and this little bit of creeks, and these are the mangrove trees. And what you can see here is these are this is not the land, but this is the submerged portion, this water. So Sundarbans being the estuarine portion with the delta. So what we have is we have high tide and low tide. We have twice a day high tide, twice a day low tide, and during the high tide, large part of the land is kind of submerged. So if you can zoom further, we're probably able to make out that some portions are submerged. So that's the forest portion, and that's an interesting part, and it's an exciting place for the eco diversity it has. It's an interesting place for the kind of livelihood people have, and it's also an interesting place because this is where the Bengal tigers originate from. But let's kind of zoom back to the area of interest, and let's zoom back to Mushuni Islands, right? And let me kind of explain this geography a little bit more. Okay, so if we look at places in this island or nearby, and if we really zoom, what we find are these agricultural plots, okay, and the little bit of houses, and within these plots you can find very clear that these are the water bodies, the natural freshwater ponds which are kind of erected. That's a natural freshwater pond. These are the paddy cultivation. This is probably a land which has already had the harvest, and this is probably still not haven't harvest. And the image which we are looking at is dated 25th November 2014. So we can go back and look at the more recent one. Okay, so that's a more recent picture, and this is about November 22nd, 2014. And what we find is a different color composition, but pretty much the same kind of activities going on, which is basically the agricultural activity. So this is what we can get a sense. Now there are a lot of things. There are just a lot of things which this simple frame can tell you, and I would try and focus on only one particular thing which we can look at. And for that, let's kind of come back to the place where we wanted to go. A little bit of tiny island on this side, and this is a place which I want to focus on. Now, this is basically my data, right? So when we look at the data, we need to understand the features of the data. So basically, what I'm interested in that all the image that is here, what does it kind of tell me? Okay, so first, this is water, this is river, so that's the data, and we need to find out, how do we detect the water in terms of numeric numbers, so that it becomes usable. If we zoom even further, these are cultivated plots, okay, given by this kind of sense. Within the class of cultivated plots, there are different stages. Some are harvested, some are yet to be harvested. These are the mangroves, which act as a natural barrier against the high tides. So we do see a lot of mangroves out here. We also see some man-made water bodies. For example, this looks like a man-made water body. If you can zoom up, so these are the freshwater body. It's usually the rainwater which has been kind of accumulated here. Um, and we will also find some places where people stay. Okay, so if we can get a better resolution, then we can make out there some of the houses are here. So that's essentially the data. Okay, so for example, here we can find some construction. So these are the houses, and this is a place where there is no grid electricity, so you're not going to find any electrical pole or anything. But that's the data which we have, right? So agricultural plot, primarily agricultural plot, surrounded by water on all sides. It's an island. This is a little bit of stream that is running, so we will not call it a water. It's more like a backwater, because this is the stream which has no origin. It just comes from one place, and it kind of, when the tide came, when the high tide kicks in, the water kind of flows in, and when the tide goes down, then the water also goes back. So that's the data which we have. Okay, and I'm interested only in this particular portion, and let's see what is it that we can do. So there is no problem statement which I'm going to share with you, but instead let me kind of present the data, and let's sniff out the problem which is apparently there in front of us. So let me help you by looking at the following. I'm going to zoom this island a little bit, okay? And what I'm going to do is, I've already explained the features of the data in terms of, this is the stream, and these are the small trees, and these are the mangroves, the places, agricultural plots, okay, southern tip of the island. So, and this the sand heads in a way. And let's kind of go back few years to the same place, and let's see what we can see. Okay, now the color texture is different. Now that will happen because it's a different camera, different kind of an atmospheric clearance. So it's not the color texture which I want to focus on in terms of looking at, but I just want you to keep focused on this particular portion, and let's see what is it that we can pick up. So that's 2006 November. The next image which we're going to look at is 2009 March, right? Now, you do find a difference in color between these two places, but that's because of the shade, and it's nothing to do with things which are happening on the ground. So let's kind of move one step more, and let's come to 2010. Okay, pretty much brightly lit. Okay, again March, 2nd March, right? And let's kind of jump to the next one in 2013. Pretty much the same kind of image which we have. So which basically means that if there is a way of kind of quantifying the data of this particular island, for example, if there is some way we could assign some numbers to the colors here, then what we are seeing earlier and what we are seeing now, there might be slight change, but what we are seeing, this one and this one, whatever is the difference, that relative difference would probably remain the same. So in other words, if we had created a quantitative number, and if we had compared the relative difference of this number between this particular plot and this particular plot, that ratio I think would by and large be unchanged if we are going to 2030, right? So that's fine. So the analytics is about thinking about this set of plots which have different colors to be able to quantify to some numbers, and then being able to track that whether these numbers are the same or they're changing, and try to find out the reasons for that. Let's kind of go back, come front, and let's look at something else. and I'm going to move to the next available date, and that's 25 November 2014, right? Now, is there a difference which we are seeing? Since I have explored this data a bit, so I probably know what the difference which we are looking at in the island. It may not be very obvious to most of you, so I probably be a good idea to kind of keep on looking and figuring out if something else is happening. And I take the one more attempt at it. Okay, one more attempt of getting the data on the next day. Okay, and that is again November 2015, and you see the difference which has now happened, right, including all the way back. So notice now this particular portion, the southern part of the island, okay, in the year 2013, okay, there, as I said, the ratio between the numbers out here and the numbers out here, whatever it was same earlier, okay, in 2010. It continued to be the same in 2013, but somewhere in 2014, the ratios have started changing. And when we look at 2015, the ratios are actually different. So which means something has happened to this part of the island and which has not happened in this part of the island, right? So whereas the ratios between the adjacent plots out here have continued to remain the same, but these have got considerably dark patch, right? So we can zoom in and we can find out these are kind of very dark patches, looks a bit ugly. Of course, this is a river, this is a pond which stays. So something has been happening to this particular portion, right? Now, what analytics tells you is that if we actually employ a technique which are able to convert this to numbers and then be able to track the differences, then the analytics will tell you, yes, there is something which is going on, which has happened between 2013 and 2014, so that something on the ground has changed quite drastically within a year. So what's that? So what do you think has changed drastically? Now, to be able to figure that out, we need to kind of look at the quantitative part and convert the colors into numbers and kind of track that. And let me show you a software which is many of you are probably comfortable with, and I'm going to use the QGIS software. And the QGIS software is again a free download. It's an extremely useful software where you can actually look at the satellite image, and then you will be able to process the satellite images. And what I've done is I've just picked up the satellite image from the Landsat 8, so Landsat 8 and Sentinel. So these are the two satellite images which are free, reasonably good. Landsat 8 has a resolution of about 30 meters. Sentinel has even a better resolution of about 10 meters. And now if we employ those images, and that's the place which we are looking at. Okay, so let's kind of look at where we are. So that's the lower portion of Sundarbans, and if I again zoom, we are going to get the island of interest, that's Moshuni. And let me kind of first show you what is happening in the October. So this is October 31st October 2014. So that's a Landsat image. If you're looking at the colors red and blue, so these are not the true colors. So normally human eye can see only three bands of colors, red, blue, and green. And there are other bands which Landsat 8 and Sentinel both capture. So we are unable to see that. But these are very useful information in terms of processing the information which we have. And then what we want to see is, if you look at this particular island, of course, it is visible. We can see a different kind of color texture, and that's what I was pointing at. That if we start looking at this island, what we are going to get is there is a difference. So the difference which I was trying to show you from what the true color is, what our eye sees, and once we plot it, or we decompose this color image into the various bands and look at various band combinations, we do find that there's a stark difference. So these are different from here, and that's why in my Google Earth image, I was actually finding some kind of difference between the two. So look at this was a darker patch, but this was not a dark patch. And when I look at here, that's exactly what's coming out. Now, there are two ways to look at this problem. One is they are different, so something must have happened that we have figured out. The second way is that we could look at actually a quantitative construct. So we are using the reflectance, and the reflectance would depend upon multiple things. So I will not get into that in this video because it's just an introduction to kind of things which we can do rather than how to do it. If you look at the reflectance, we do find that there is a difference. So all these numbers are in the negative. Okay, so these are kind of negative numbers. These are kind of reds are kind of some positive numbers, and these blues are also there's a difference between the blue colors, this huge red color. These are 0.5. There are some positive numbers out here, okay, and there are some negative numbers out here. So if we start kind of zooming a whole lot, okay, we will find that there is some amount of difference between how the numbers in this pixel start changing, which gives me an idea that there is a difference. So which means even if the human eye was not looking for detecting it, if we actually start developing algorithms which looks at each piece of this land as these possible numbers, then the change in the numbers will tell me something, that there is something which is happening which we need to explore. We look at the same thing. The same thing is true even in November of 2016. So again, if you look at it, now the differences are much starker. So these are kind of all numbers 0.5 and above. These are all negative numbers, and these numbers are between this and this. So perhaps it's giving me an idea that this patch, what has happened, is probably something to do with what's happening on the left hand side, right? So essentially what analytics will tell me is they will detect this pattern, but it will probably not be able to give me an answer that why we are seeing what we are seeing. To figure out what has happened, what we need is apply a little bit of domain knowledge, understanding the applications, and let's go back to where we are and let's figure out what has possibly happened. So our QGIS image processing tells us that something that happened here has got to do with something which is out here. And what's out here? That's the river. The river is out here also. So the question is, why did something happen here and not on this side? Well, here lies the answer. These are the mangroves. So the mangroves are a natural barrier against the tide. So when the tide water comes and hits the bank, these are all silt roots. So these roots are kind of loose, and it absorbs a lot of the water waves and the shock, and therefore the intensity with which it kind of hits the land here is far less than what we have here. So here the mangroves are not there, and therefore the water with the full intensity hits on this side, and somewhere between 2013 and 2014 the water rushed in, but it did not gush in, it can probably sipped in. And what we have right in the middle of the island is an elevated road, which is not a pakka road, which is not a cement road, but it's an elevated road. So the water rushed in, but it could not go on this side. So it got trapped here. Over time, it also went back. But this is salt water, which means once it has entered, this part of the agricultural plots are pretty much going to be infertile and worthless for a while. And that you can see from 2014 and all the way for the next 2-3 years, and it will last for another couple of years, where this portion of the land, you're not going to see any agricultural activity. So what does that mean in kind of policy, or what does it mean in terms of solving the problem? A lot of things. So the idea, so therefore, what we can make out is, in the large scheme of things, to find out a small tiny island and a small portion of an island will have a problem. we will not be able to identify that unless we are actually employing schemes like that. Because the only way we could have found that problem is if somebody from the ground is reported, and then the government had to send officials to cross check and verify. That would take its own time, it can involve a lot of transaction costs. But here we have an algorithm which can easily detect that there is a portion out here which is going to have and crop failure, which is not a weather phenomenon, because large part of the area, even the local neighborhood is not going to suffer from what's going on, but they are going to suffer, and therefore we can make the state machineries geared up for it. So maybe we realize that they might require some extra support in forms of energy and all, much more than these people would need. So it would be a good idea from the policymakers to ensure that for inhabitants of this island and people who have this particular portion, this percentage of people would definitely require some support and make the arrangements required, whereas the rest of the parts are okay and they are not unaffected, at least by this kind of phenomenon, and they should be able to go and do things the way they are. Now, that I think is an interesting thing which analytics can do. It's actually solving a problem. It's solving a problem of detecting about what portion in a small geography are going to face some kind of an income shock. Without the techniques in analytics or things which we have kind of discussed, the traditional way would be to kind of somebody reports and then send people to cross check and verify. Here, it's pretty costless, it's pretty real time, because you know that something is going wrong, and then you just need to do one round of validation. And in fact, if we can crack the algorithm well, which is probably not so difficult, looking at the difference in the color and the kind of changes in the number, we may be able to predict what goes wrong elsewhere. So it's like a one-time or a very infrequent intervention, what we call, you train the model once, and then you have an algorithm which can detect such behavior elsewhere. Okay. So I hope what I could demonstrate to you is an example where we are solving or we can solve traditional problems which are complicated, which have different kind of ways to do it, but we are solving by pure data science, by extracting a different kind of data, which is looking at the pixel data, the video data. It doesn't mean that the traditional methodologies are going to take a backseat, because they are very important, because after all that analytics data is telling is that there is something that is happening, and to find out what is happening, you need to be able to employ the traditional ways of finding out what is happening. So you will need people to go on the ground. The advantage which analytics brings is that we actually have an early detection. We know something is not right, and then we can go and find out what the problem is. So thank you for being patient, and I look forward to see you next time.